Hey everybody, so I'm going to do another video to review the nitrogen cycle that we did in class today. So let's talk about the nitrogen cycle. Alright, so if you didn't know this, about 77% of the Earth's atmosphere is this N2 gas. But one problem with this is that the N2 gas is extremely unreactive. Alright, so let's say 77% of atmosphere is N2. Alright, so N2 is very unreactive. When I say unreactive, I mean it doesn't really do anything. It just kind of hangs out. It doesn't, react with anything. And the reason for this is because it has a triple bond between the two nitrogen atoms. So it looks something like this. Alright, so it is sharing 6 electrons between it. So that bond is really, really strong. Alright, there are two ways that we can break this bond. Alright, so two ways to break triple bond. Alright, one of them is going to be lightning. Alright, so lightning is going to strike the N2 molecule and then break it apart. Alright, and then it's going to fall to Earth as NH3, which is ammonia, in rain. Alright, the second way that we can break the triple bond is we can use these things called nitrogen fixing bacteria. Alright, and they have an enzyme that allows them to break the triple bond. So nitrogen fixing bacteria have an enzyme that allows them to break triple bond. Alright, that leads me into our discussion, our first process in the whole nitrogen cycle. Alright, so I'm going to switch colors. And the first process that we really need to talk about is called nitrogen fixation. Alright, so nitrogen fixation. Alright, so nitrogen fixation is the whole process in which bacteria in plants, they take N2 out of the air and they turn it into ammonia, and then they turn it into ammonium. Okay, so nitrogen fixing bacteria in plants, nodules, and roots convert ammonia, and ammonia is NH3. Oh crap, I'm sorry, this is wrong. Convert N2 into ammonia, which is NH3. Alright, then ammonia, which is NH3, is converted into ammonium, which is NH4 plus, which is put into soil. Alright, so these nitrogen fixing bacteria, they get a home out of the plants, and the plants get nitrogen from them, so it's kind of like the mutualistic association. Alright, so these nitrogen fixing bacteria, they can take N2 out of the air, convert it into ammonia, and then the ammonia can be converted into ammonium, which they then put into the soil. So if you want to talk about nitrogen fixation, it's basically N2 is going to go to NH3, which is then going to be converted into NH4 plus. So this is dinitrogen gas. This one here is ammonia, and this one here is ammonium. Alright, so this ammonium is going to be put into the soil, and then that's when the next process can happen, and we'll talk about that one now. So whenever we put this ammonium into the soil, plants don't actually want to use ammonium. They would much rather use nitrate, which is actually NO3 minus. Alright, so we've got nitrogen fixation. After nitrogen fixation, this ammonium goes into the soil. Alright, and bacteria in the soil are going to convert the ammonium into nitrite and then into nitrate. Alright, so the next process we really need to talk about is this whole process called nitrification. Alright, so nitrification, bacteria in the soil convert ammonium, which is NH4 plus, into nitrite, which is NO2 minus, then into NO3, which is nitrate. Okay? And nitrate is really the one that plants want. They want to uptake. Alright, so plants uptake NO3 or nitrate into their roots. Alright, so here's the whole process down here. We've got this whole nitrification process. So we've got NH4, which is ammonium, is being converted into NO2, which is nitrite, and then it's converted into NO3, which is nitrate. Alright, so we've got ammonium here, nitrite, and nitrate. Okay? So, let's talk about the two bacteria, or the two species of bacteria that do this. Alright, so to convert ammonium into nitrite, you're going to need the Nitrosomonas bacteria. So, Nitrosomonas bacteria. Alright, and then over here, to convert the nitrite into nitrate, you're going to need the Nitrobacter bacteria. Alright, so if you notice, a lot of the things in the nitrogen cycle are actually being done by bacteria. So up here we have the nitrogen fixing bacteria that were existing in plants, nodules, and roots. And then down here we've got the Nitrosomonas bacteria and we've got the Nitrobacter bacteria. Alright, so ammonium is converted into nitrite and then nitrate, and then plants will uptake the nitrate into their root system, which they then use as nutrients. Alright, so the next process that I want to talk about is what happens to this NO3 when you have what they call a reducing environment. So the next one that I'm going to talk about is this whole process, and it is known as denitrification. Alright, and denitrification is going to be this process in which NO3, which is nitrate, is converted into gas. So nitrate gets converted into dinitrogen gas. Alright, so NO3 minus is being converted into gas. Alright, so again, this is nitrate. This is dinitrogen gas. Alright, and who is doing this? They get grouped together into this giant group of bacteria known as denitrifying bacteria. Alright, so like I said earlier, this can only occur in these places called reducing environments. So only occurs in reducing environments. Alright, so what is a reducing environment? Well, a reducing environment is where there's no access to oxygen. Alright, so what's a reducing environment? No access to oxygen. So think about places that don't have a lot of access to oxygen, like a swamp or a marsh, or sediments that are at the bottom of the ocean or the bottom of a lake. So all of these are places where this nitrate will get converted into N2. Alright, so examples include swamps, marshes, bogs, really anything that's swampy. And I'm going to put ocean sediments here as well. Alright, so we've got this whole process of denitrification, and the denitrification process is basically taking the NO3 nitrate in the soil and it's converting back into the N2, which is dinitrogen gas, which then just goes up into the atmosphere to join the rest of the 77% of Earth's atmosphere. Alright, so now we need to talk about the next process, and the next process is where plants and animals, they basically take up nitrogen into their bodies, and it is called assimilation. So assimilation is where plants and animals take up inorganic nitrogen, like nitrate, and convert it into organic compounds. Alright, so you need nitrogen in your body for things like your DNA and certain proteins and stuff like that. So this is the whole assimilation thing. This is basically where you are eating plants or you're eating animals to get your daily dose of nitrogen. Okay, so that's assimilation. And usually the assimilation is going to be inorganic nitrogen to organic nitrogen, just like that. Alright, the last process that I want to talk about also starts with an A, and it looks like I'm running out of colors, so looks like I'm going to go with green. Alright, so the last process is called ammonification. And ammonification is actually the opposite of assimilation. So when an organism dies, the nitrogen that's in their body is going to go back into the soil. But we're going to need something or someone to convert this organic nitrogen into ammonium. Nitrogen into ammonium. And this is going to be done by decomposers like fungus and bacteria. So decomposers, bacteria, so we could have fungus here or something like that. And that's the whole process of ammonification. Alright, so now I want to talk about the whole process of nitrogen, where does it go, that kind of thing. Alright, so we're starting out with the N2 that is in the atmosphere. Alright, it is going to be taken in by these nitrogen-fixing bacteria. And it's going to be turned into NH3. Alright, and then it will be turned into NH4. Alright, so just kind of a recap for you. NH3 is ammonia, and then NH4 plus is ammonium. Alright, so the ammonium is going to be converted into NO2 first, which is nitrite, All right, and it's going to be done by the specific bacteria. They are known as the Nitrosomonas bacteria. So this is Nitrosomonas bacteria. All right, after the nitrite is formed, it is then going to be turned into nitrate. All right, so we've got NO2 getting turned into NO3, which is nitrate. And this is going to be done by the Nitrobacter bacteria. So I'm running out of colors again. So Nitrobacter bacteria. All right. In waterlogged soils or waterlogged areas, places that don't have access to oxygen, the NO3 is going to be turned into all right, and this process is known as denitrification. Okay. This whole process down here at the bottom, in which ammonium is converted into NO2 and then NO3, this whole process down here at the bottom is called nitrification. All right, so nitrification is going to go down here at the bottom. So nitrification goes from ammonium to nitrite to nitrate. If this is in a reducing environment, then we're going to have denitrification occurring. All right, and then the N2 that we literally just created will go back through this whole process, and it'll circle back over to here, where it can start the entire process all over. Hence the reason why it's a cycle. All right, here is another way that the ammonium can get into the soil. Let's say that this is brown. Let's say that all of this is happening in the soil down here. All right, let's say that there's some sort of animal, and you're going to laugh at my drawing because my drawings are terrible. Let's say that this is a dog or something. All right, this is a dog. Here's his eye, and then he dies. Oh no. The body that he had is going to degrade into the soil. So decay, and ammonification is now going to occur, where the whatever organic compounds he has in his body will then go into the soil, and then there's more NH4 here, which can then be converted into this, and then the whole process continues that way. Let's say that there is a tree over here. Right, there's a tree right here that's like that. It's taking up the NO3 into its roots like so. This process over here would be assimilation. And then when it dies, it will then go back into the soil, and this whole ammonification process will occur. So then all this just keeps cycling and cycling and cycling. All right, so I hope that helps. Please let me know if you have any questions. Have a great day.